So welcome boys and girls. This is the video to go along with Unit 1 Lesson 3. And the learning target is, I can identify equations that have one solution, no solution, or an infinite number of solutions. So the do now is first to just solve these equations. So we have two multi-step equations and we have to think order of operation. So the first step is if we see parentheses to get rid of those parentheses. So we have to multiply 3 times x is 3x, and then a 3 times a negative 2. Remember that minus sign that's in front of the number always is with that number. So 3 times a negative 2 is a negative 6. Bring down a positive 4x. Now we have 1/2 times 6x. So we always, when you have a half times a number, just think of halving that number. So a half times 6 is just what's half of 6? 3. So 3x. And then a half times negative 4 is what's a half of negative 4? Negative 2. Now we have three terms on the left side. So we're going to combine the 3x and the 4x. And 3 plus 4 is 7x minus 6 equals 3x minus 2. Now we want to bring the smaller x to the larger, so you subtract 3x from both sides. Subtract 3x from both sides. And we're left with 4x minus 6 equals negative 2. Now we want to get the x alone, so we got to move the negative 6 over by adding 6. Remember, you always are using inverse operations. So you have 4x equals a negative 2 and a positive 6 is a positive 4. And then we divide by 4, x equals 1, which is answer choice B. Down here, on the left side, we have 4x minus 8 minus 1, so we can combine the negative 8 and the negative 1. Those negatives are in front of those numbers, so they are staying with those numbers. So we have 4x and a negative 8 and another negative 1 is a negative 9. Because think of negative 8, it gets one more negative, so that's how we get negative 9. Equals, now we distribute 5 times 2x is 10x, and 5 times negative 3 is negative 15. Now we need to combine like terms on opposite sides, so we need to use the inverse operation by bringing the smaller x to the larger. So you subtract 4x, and you're left with negative 9 equals 6x minus 15. Add 15 to both sides to get the x alone. You're left with a positive 6 equals 6x. Divide by 6, and again, we have x equals 1. And this was not a multiple choice, so you would just circle your answer and we are done. So for this question, they want to know about how many values of x make the following equation true. So they want to know how many numbers can you substitute in for x that will make these sides equal to each other. And the only way you will know this, and they want to know, how can you be sure? Think of like, how do we know definite answers in math? That's right. You are always solving. You have to solve for that answer. So if you always solve the equation that's given to you, you will figure out how many values of x, and if so, what that value of x is that can substitute in to make 5x plus 2 equal 3x plus 8. So let's just solve this. We have x's on both sides, so we need to get them together. We always want to get the x's together, so we minus 3x on both sides. And we have 2x plus 2 equals 8. Now we got to move the 2 over to get all the numbers on one side and all the x's on the other. So we have 2x equals 6, divide by 2, divide by 2. So this is x equals 3. So for this equation, yes, there is a value of x that makes the equation true. And this is one solution. There's only one solution that it makes true. So you could only substitute in x is 3 and for both sides, and it will be the only number that when you substitute it in, 5x plus 2 will equal 3x plus 8. There's no other number. So if you ever solve an equation and get x equals some number, you know that that is the one and only solution to that equation. There is no other answer to that. Now, the same thing, they want to know, does x equals 3 satisfy the following equation? So whenever they give you a value of x, you take that number and you're going to substitute it into wherever x is. So 3, everything else stays the same. So I bring down the 3, substitute in 3 plus 5 equals 2, bring in the substitution of 3 plus 8. Now just solve. 3 times 3 is 9 plus 5 equals 2 times 3 is 6 plus 8. And when we add them, we have 14 equals 14. So yes, x equals 3 does satisfy this equation. Now for the next one, let's see. We have again, does x equal 3 satisfy this following equation? Show your work by substitution. So we're going to substitute the 3 in wherever we see the x. So 4 times 3 plus 1 equals negative 2 times 3 minus 7. 4 times 3 is 12 plus 1 equals negative 2 times 3 is negative 6 minus 7. So on one side we have a positive 13 because 12 plus 1 is 13, and negative 6 minus 7, I'm sorry, negative 6 minus 7 is negative 13. So remember, boys and girls, 13 and a negative 13 are not the same number. They are opposites, but a positive and a negative of the same number are not the same. So no, x equals 3 does not satisfy this equation because the x is gone and now you have some number 13 equal to another number negative 13. And we know 13 can never equal negative 13. So therefore, this does not satisfy the equation, and this would be called no solution. So whenever you solve an equation and you get an answer where your variable disappears, as you see, there's no more variable, and you have a number equals some other number, there is no solution, okay? There's no number that's going to satisfy that. And down here, we have, does x equals 3 satisfy the following equation? Again, substitute that in. So here, that would be not a solution. And here, so we're going to substitute that in, and now we have 3 places to go. So we have 3 times 2 parentheses. Anytime you substitute in also, make sure you put parentheses around that number. So 8 parentheses 3 minus 4 minus 2 parentheses 3 close parentheses plus 10. So you guys can put that all right into the calculator if you want, but if not, I'm just going to write 3 times 2 times 3 is 6 plus 2 equals 8 times 3 is 24 minus 4. A negative 2 times a positive 3 is a negative 6 plus 10. So now I'm just going to type each side into the calculator, and when I do, I have 24 equals 24. So yes, x equals 3 does satisfy this equation. When you substitute it in, you're going to have the same number on both sides. So if you get 24 equals 24, you know that x equals 3 is an answer to that because it will make each side of the equation equal to each other. Now they want you to also check for x equals 1 and x equals 2 and x equals 5. So we're going to just start with x equals 1. So we're going to substitute in 3 times 2 parentheses 1 plus 2 close parentheses equals 8 times 1 minus 4 minus 2 times 1 plus 10. So I'm just going to substitute, boys and girls. You can put this left side into the calculator just as you see it with parentheses and all. So when you put that into your calculator, you're going to get an answer of 12 equals, and the same thing here. If you just type this whole right side into the calculator as is, you get 12 equals 12, which is yes. So now we have also x equals 1, and we just had x equals 3 equal as solutions. So yes, that's a solution as well. So if you have more than one x value that satisfies the equation, that means that when you substitute it in, both sides are equal to each other. That would be called that this equation will have infinitely many solutions. So we will get more into it within the next slide, but if you ever solve an equation and you get the same number on both sides, like this, and when we substitute in and we get the same number on both sides and we substitute in multiple different numbers, then we know that it has infinitely many solutions, because it's not one solution, because it's not saying only x is 3 works for it, but now it's saying x equals 1. And now you could try x equals 2 and x equals 5, and they would both be equal to each other also. So therefore, this means any number that you want to substitute in will work and solve this equation to make it equal on both sides. So here, in 6th and 7th grade, we learned that every equation only has one solution, and the solution that makes both sides of the equation balanced will equal. So, like we said, if we solve an equation and get x equals 2, we know 2 is the only answer to that equation. So now we have this equation. So let's explore it. Let's just start by getting rid of the parentheses. So 2 times 4x is 8x, and 2 times 1 is plus 2 equals 8x plus 2. So what is the solution to this equation? Well, at this point, we have the same expression on both sides. If you can see that, we have 8x plus 2 equals 8x plus 2. So we know that this is exactly the same. So if we know that this is going to be exactly the same, at what point during the solving process can we stop and determine the number of solutions? Well, if we want to take it a step further, we know that in order to finish solving this, we would have to subtract 8x on both sides to get all the variables together. Now we have 2 equals, well, 8x minus 8x cancels, and now we have 2 equals 2. Okay, so first we had the same expression on both sides, and now we have the same number on both sides. So that should be a hint to us that this equation will have infinitely many solutions. And you know that because the equation is the same on both sides. So for no matter what variable I substitute in for x, I'm going to get the same answer always. So let's just show for an example. If I take x equals 2 and substitute it in, so I have 8 times 2 plus 2 equals 8 times 2 plus 2. 8 times 2 is 16 plus 2 is 18 equals 8 times 2 is 16 plus 2 is 18. Good. It's the same on both sides. Now let's try x equals negative 3. I have 8 times negative 3 plus 2 equals 8 times negative 3 plus 2. 8 times negative 3 is negative 24 plus 2 is negative 22. And then 8 times negative 3 again is negative 24 plus 2 is negative 22. So again, same number on both sides. So, boys and girls, if you have an equation and you begin to solve it, and when you start combining like terms and get rid of parentheses, if you see that it is the same expression on both sides, you know your answer will be infinitely many solutions. Because no matter what value you put into 8x plus 2, it will always equal 8x plus 2. That will never change, okay? And as you can see here, no matter what number I substituted it in, when I solve it, I got the same number on both sides. And I had different x values. So therefore, any x value I substitute in will work. Okay. And then for this one, so again, we want to, right? for this one, we're going to explore this one as well. So let's start by getting rid of the parentheses again. So 2 times 4x is 8x, and 2 times 1 is a plus 2, equals 8x minus 5. So like we saw before, we had the same expression on both sides. Now, we have 8x plus 2 equals 8x minus 5. So it's not the same on both sides. So we cannot finish solving. We cannot just stop here. We need to continue solving in order to see what our solution will be. So let's subtract 8x on both sides to get the x's together. And again, the 8x's are going to cancel out because an 8x minus 8x gives us 0. So what we're left with is 2 equals negative 5. Now, that's a little odd to me because 2 can never equal negative 5. They are not equal to each other. Nowhere. Never. Can't happen. So therefore, if you finish solving an equation and there are 2 different numbers and they're not equal to each other, this will tell you that there is no solution to that equation because no value of x, when you substituted it in, will ever give you 8x plus 2 will equal to 8x minus 5. Think about it. If I multiply a number times 8 and then add 2 to it, will it ever equal that same number times 8, but then now I subtract 5 from it? No. And I'm going to show you an example just to give you a visual as well. So x equals 2. Again, I'll substitute that in. X times 2 plus 2 equals 8 times 2 minus 5. So 8 times 2 is 16 plus 2 is 18 equals 8 times 2 is 16 minus 5 is 11. 18 will never equal 11. And if we have x equals negative 3, 8 times negative 3 plus 2 equals 8 times negative 3 minus 5. So we see here, 8 times negative 3 is negative 24 plus 2 is negative 22. And 8 times negative 3 is negative 24 minus 5 equals negative 29. Can negative 22 ever equal negative 29? No. So therefore, for any value of x that we substitute in, they will never be equal to each other. And you can also, so if you want to solve all the way to the bottom, you would know that here. 2 different numbers, never equal to each other. But now, if we want to look at their expressions, you can say, okay, they have the same x coefficients, but different numbers being added or subtracted. So you can stop solving. If they're just asking for how many solutions are there, so you would know that your options are either one solution, no solution, or infinitely many solutions. If they just want to know how many solutions there are, you can stop here. And you can say, I know that there will be no solution because they have the same x coefficient, but then they're adding and subtracting different numbers. But if you don't see that, finish solving all the way through and get to the end where you see 2 numbers and they're going to be 2 different numbers. So either way, if you could view it from the expressions or you could view it from your final answer. That's 2 different ways to identify your answer of no solution, okay? And let's just go back for a moment. Here, you could have stopped here and said infinitely many solutions because it's the same expression on both sides. 8x plus 2 is always going to equal 8x plus 2. And if you don't see it from there, you can go and continue solving to the very end where you get a number equals the same number. Okay, and that will always give you infinitely many solutions. Okay, so now we're here. These are ones that if you want to try solving right now, You could stop, pause the video, and then come back and check your answers. But they want you to solve each equation and determine which one has no solution. So also, I'm going to challenge you guys to also then figure out what is the solutions to the other ones. So you also have one solution, it could be, or infinitely many solutions. And they're right here in your learning targets. So also with identifying no solution, identify which ones have one solution and which equation has infinitely many solutions. So if you try it on your own, you come back. Now we're ready to go over it. So we have A. We need to get the x's together on opposite sides. So we're going to bring the smaller x over to the larger. And now we have 2x minus x is x equals 1. So boys and girls, again, if we ever just have a value that we solve for and it's x equals 1, we know that that is one solution. That is the only value of x that will satisfy that equation. So a little hint, if you look at the expressions on both sides, if you want to stop solving from your original equation, your hint would be that there is different x coefficients. And what I mean by that is the numbers in front of x are different. So if you see that this x has a 2 in front of it, and here, every x, if it's just standing alone, the number in front of it is always 1, but we just never will write that. So if we see that this x has 2 and this x has 1, we know that we're always going to have an x value. It's never going to cancel out. So we're always going to solve for an answer of x equals some number, and whatever that number is will be the one solution. So again, if they don't want that answer, and they're just asking you how many solutions is it, you can stop solving right there and say there is one solution, because you could see the x values, the numbers in front of the x values are different. Now we have B. We have 3x plus 4 equals 3x plus 1. Some of you might have stopped right here and said, oh, I know this is no solution. And you would say it's no solution because it has same x coefficients but different numbers being added and subtracted. Well, different numbers being added for the sake of this example. But if you don't see it, that's fine. I might not see it either, so I need to solve it. And my first step is always to get the variables together. So I subtract 3x on both sides, and I am left with the 3x's on the left side cancel out, and I just have 4 equals, and the x's over here cancel out. I'm left with 1, and therefore 4 equals 1, which we know is not true. 4 will never equal 1, and therefore you would get your answer of no solution. Last but not least, we have 4 times 3x minus 2 equals 12x minus 8. Now, I don't see the solution from the way it's written at the moment, so let me see if I get rid of my parentheses. So I'm going to distribute. 4 times 3x is 12x, and 4 times a negative 2 is a negative 8. Equals, bring down the other side because there's nothing to combine, there's no parentheses. Now again, some of you might stop right here and say, oh, 12x minus 8 equals 12x minus 8. It's the same expression on both sides. So I know this will have infinitely many, I just sounded it out for all of you to spell, many solutions, because it is a tricky word. And this has infinitely many solutions because it's the same expression on both sides. Okay, but again, some of you might not see it. I wouldn't, so I'm going to need to keep solving. So I'm going to minus 12x on both sides. and minus 12x. The x's cancel out here. I'm left with negative 8 equals, the x's over here cancel out also, negative 8. So again, now we see negative 8 equals negative 8. That is the same answer on both sides. So that is the same number. The number will always be equal to itself. That will never change. So if you solve an equation and you get the same number on both sides, you know they are equal to each other, and that equation will have infinitely many solutions. Okay, and how can we know how many solutions without actually solving it? We just went through that. So that was when you could look at every single equation without finish solving it to the end and identify based on the values in front of the x and the numbers being added, or if you could see that their expressions are equal to each other, then you know it will be infinitely many solutions. Okay, so this was a state exam question, and this, if you see this, that always means state exam, January 22nd, 2017. So try this question on your own. It's working backwards. So for what value for the constant p will result in no solution for this equation? So if we want no solution for the equation, think of what, or go back to your notes that we just wrote. In order for an equation to have no solution, the x coefficients have to be the same, and the number added or subtracted is different. So P is being distributed to everything in there. So P is going to be some number that when I multiply it times 2, I need it to be 6 because I need, in order to, for this equation to have no solution, I need their x coefficients to be the same. So what number times 2 will give me 6? And you can use your answer choices. It is a multiple choice question. So if you are unsure, take your calculator. Say if I substitute in negative 3 times 2, I get negative 6. Does that equal 6? No. Remember, positives and negatives are never the same. Now if I substitute in 0 and I multiply it times 2, if I was to distribute p times 2, so 0 times 2, would I get 6? No, that's 0. Again, p would be now 1.5, and I have to multiply it by 2. So 1.5 times 2 gives me 3. Again, that's not 6. So let's hope that D is our answer. 3 is what we substitute in for p, times 2 equals 6. So yes, D is our answer. And so let me show you. If we do substitute it in the whole equation, 3 times 2x plus 5 equals 6x plus 7.5. We have 6x plus 15 equals 6x minus 7.5. And right there, we would stop solving and say, I know this has no solution because the x coefficients are the same, but when you add 15 to that number, it's never going to be equal to subtracting 7.5. So you know that that will have no solution. There's no number that when you substitute it in will make the expressions equal to each other. Okay, so here we have Mickey and his friends, Minnie and Donald. We're each given an equation to solve. Mickey has 2 times x plus 10 minus 17 equals 5 plus 2x minus 2. Minnie is the other equation there, and Donald's. So how many solutions does each equation have? I the next slide, we did leave some room for you to solve, so I'm just skipping to this. So we need to try these, and I want you all to try these on your own, then come back and check your answer. So once you're ready to come check your answer, you'll click play on the video. So I'm going to start by solving. You have to get rid of the parentheses, so I have 2 times x is 2x, and 2 times 10 is plus 10, minus 17 equals. On this side, there's no parentheses, but I do have a 5 and a negative 2 I can combine. So I'm going to bring down the 2x, and 5 minus 2 is plus 3. On this side, I have a positive 10 and a negative 17. So I have 2x and a plus 10 and a negative 17 gives me a negative 7. If you are unsure, please check it in your calculator. Okay, bring down the 2x plus 3. So some of you might be able to stop here and say, I know that this will have no solution because the x coefficients are the same and the numbers being added and subtracted are different. But if you cannot stop right there, keep solving to the end. No big deal that is, because it's only one more extra step. So minus 2x on both sides to get the x values together, and we're left with negative 7 equals 3. And right there, negative 7 will not equal 3 ever, so there is no solution. Over here, we have 5x plus 3 minus 3x. So we have 2x values that we can combine. That negative sign is attached to the 3x. When we combine a 5x minus 3x, it's 2x plus 3. Bringing it down equals, we have the distributive property now. 2 times x is 2x. 2 times 3 is plus 6 minus 5. On the left side, we're good because we have just an x and a number. On the right side, we have 3 values, so we need to combine 2 of them, and we see the positive 6 and a negative 5. So 6 minus 5 will give us positive 1, and everything else I'm going to bring down. 2x plus 3 equals 2x plus 1. Oh, wait. I'm sorry. Let's go back to Mickey. My mistake here. See, we all make mistakes. 2 times 10 is 20. Miss Gadgie messed up there. See? And now when we combine 20 and a negative 17, we get a positive 3. Then when we have 2x plus 3 equals 2x plus 3, you could have stopped right there and said that this has infinitely many solutions. I am so sorry, boys and girls. That's my mistake. But say we all catch our mistakes and we'll fix them. So now we have infinitely many solutions because we see the same expression on both sides. And again, if you didn't see that, you would always just get the variables together by subtracting 2x on both sides. And now we're left with 3 equals 3. So here, it's the same number on both sides, which would still give us infinitely many solutions. For mini, let's go back to mini. Now here, this is when, and I promise my work is correct right now, it is no solution because the x values are the same and the numbers being added are different. Now, if you don't see that, you combine the x's, minus 2x, and we're left with 3 equals 1. 3 will never equal 1, so again, meaning no solution. And last but not least, we have Donald. So 2 times x is 2x. 2 times a negative 3 is a negative 6 plus 9 equals. On this side, we have 3 terms, so we're going to combine the 5 and a negative 1, which gives us, I'm going to bring down the x, plus 4. Now on the left side, we have to combine a negative 6 and a positive 9. So x that gives us plus 3 equals x plus 4. So if they're just asking for the number of solutions, you could stop here and say one solution because we see that there are different x coefficient values. So we know that we will always have an x value. The x's won't cancel out. But if they want the actual answer and you still are unsure of it, you can go and finish solving this. So we're going to bring the smaller x over to the larger. And now we have 2x minus x is x. And remember, this is a 1 in front of that x. Brings down the 3 equals 4. Minus 3 minus 3, x equals 1. And therefore, that is our one and only solution. X can only equal 1. It will never equal anything else. Okay? So this is a summary part. This is where you would just take what we just have been saying. How can you tell that an equation has one solution? So you're verbalizing it. Like, how do you know when a solution will have one solution, no solution, or infinitely many solutions? So you're just writing. You know that it will have one solution when what? So if you want to go back to our notes from before, you can. That is fine. But take a second, come up with your own example, and then come back and check your work. So if you have one solution, you know that the x coefficients are different. So as long as you make any equation where the x values on each side of the equal sign are different, you could have 3x plus 2 equals negative 5x minus 9. Anything, as long as the x values are different. You know you have no solution when the x coefficients are the same and the number being added slash subtracted is different. So an example is just make sure you have the same x values. So 5x plus 1. Now we have to still have the same x. 5x. Pick a different number to add or subtract. Minus 3. Anything that has the same x's, and then you have two different numbers being added or subtracted. And last but not least, we have tell when the equation will have infinitely many solutions. When you can just say when they will have the same expression on both sides. So if you make up an expression and it's 9x plus 7, it has to be the same. So just write that same expression, 9x plus 7. And we are done with the summary page. Okay, we have a few more. We have 6x plus 20 equals negative 6x minus 20. So here, they're asking, use what you know to help solve these equations. Let's look at our answer choices. Will this have no solution? No, because the x values are different. So we know in order to have no solution, they have to be the same. And for infinitely many solutions, it has to be the same expression on both sides. Positive 6x is not the same as a negative 6x, so no, that's out. So therefore, we are solving this, boys and girls. So we have to figure out what that one answer is. So we have to start by bringing the smaller x to the larger, add 6x to both sides, and we're left with 12x plus 20 equals negative 20. Subtract 20 on both sides, and we're left with 12x equals negative 40. To get the x alone, we have to divide by 12 because they're attached by multiplication. And the opposite of multiplication is division. And we have, if you type this into your calculator, negative 40 divided by 12, you will get negative 10 divided by 3, which is answer choice A. And make sure if you're using the calculator and it gives you a decimal, click the math button, hit fraction, and it will change it to a fraction, and you should get the fraction negative 10 divided by 3. And for this equation, we're going to distribute. Negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24 equals, remember, if we multiply anything times a half, you're halving it. So that's just 5x. And a half times negative 6 is half of negative 6 is negative 3. So we're going to keep solving here because we know we have one solution since the x coefficients are different. We're going to bring the smaller to the larger. So negative 16 is smaller than a positive 5. Negative 16 is all the way on the negative side of the number line. So we're going to bring that over. We have a negative 16x, cancel it out, plus 16 on both sides. We have negative 24 equals 21x minus 3. We have to get the x alone, so we add 3 on both sides. And we're left with negative 21 equals 21x. Divide by 21. Divide by 21. X equals negative 1, which is one solution. Okay. Kermit looks at this equation, negative 6x minus 30 equals 6x minus 30. He says there is no solution. Is he correct and justify your answer? Yes, using words. So in order to help you, you should solve this. If you see it right away, you can say, okay, I know that this will have one solution because the x's are different. It's a negative 6x and a positive 6x. They are not the same. So this will have a solution, and it will have one solution. So if you see that, that's how you know that there will be no solution. But if you don't, you can come and write this down on the side and solve it. So you bring this down, and let's see, bring the 6x over, bring the smaller to the larger, and we're left with negative 30 equals 12x minus 30. Now we got to get x alone, so we add the 30 to both sides. Please do not stop solving here. A negative 30 plus a 30 is 0. 0 is a number. It is on the number line. That does not mean that there is no solution. It's a number. So you bring down 12x. You could finish solving this. You still have the x there. Divide by 12 to get x alone. Divide by 12. And 0 divided by any number still gives you x equals 0. And that does not mean no solution. X equals 0 means one solution. And that is your only solution. So you can say there is a solution. Well, there is a solution. X equals 0. So Kermit is not correct. And then we'll be done. So boys and girls, anyone, please, if you see x equals 0, do not say that is no solution. That x value is the only solution, which is 0. And down here is another question from the state exam. So they want us to solve it. So we're going to just distribute. 8 times j is 8j. 8 times negative 4 is negative 32. Equals 2 times 4j is 8j. 2 times a negative 16 is negative 32. Right here we have the same expression on both sides. So this will be infinitely many solutions. And if you did not see the answer from there, you can keep solving. So you would subtract 8j on both sides, and you would be left with negative 32 equals negative 32. Okay, so this slide is a productive struggle. So you are supposed to sit there, think a little bit, and really try to understand what the question is asking. So they want you to fill in the blank so that the equation will have the type of solution shown, and you could show will work. With these, not there really isn't a lot of work unless you're going to explain it in words. So you know you need to have a solution of no solution here. So in order to have no solution, we know that the x coefficients are the same, but the numbers are different that are being added and subtracted. So if I have a positive 5 here, what would I need to substitute into here? Now, we're going to have a multitude of answers, so that means every single one of you are going to pick something different. But as long as it's any number but 5, you will always have no solution because you know that the x coefficients have to be the same and then the numbers being added and subtracted are different. So it just can't be 5. You can't make it the same as what's on the left side. B, we need infinitely many solutions. So this means we need to have the same expression on both sides. So they need to look exactly the same. They need to be equal. So if this side has 1/3 x plus 5, we know that the other side needs to say 1/3 x plus 5. So the only answer is 5. And C, we need one solution. So we just know that the x coefficients have to be different. So we see that this side has a 2x. This side then cannot have a 2x. So again, these answers will vary. So it will be any number but 2. So if you picked negative 100, 5, 7, 10, whatever number you choose, as long as it's not 2, then you are correct. Next, we have 3 equations we're going to end up solving. So let's see what the directions say. Solve the equations below and identify if they have one solution, no solution, or infinitely many solutions. So in order to solve these, some of them, like we said, we don't need to solve. If we can just identify right away the solution, state the solution. So 15x plus 10 equals 15x. We know that they have the same x values, and this has a positive 10, and this side has plus 0. If we don't have any number being added or subtracted, it's always just plus 0. So when you have the same x and different numbers being added and subtracted, this is no solution. Now for number 2, I'm going to just move these down so we have some room. I can't see what the solution will be from there, so I'm going to need to do some work. And first, get rid of these parentheses to distribute. So 3 times 6, excuse me, is 18. And then 3 times a negative 4x is negative 12x equals negative 2 times 6 is negative 12x, and negative 2 times negative 9 is a positive 18. If you see this, you could recognize that the x values are the same, because look here, this is a negative 12x. This is a negative 12x. So right now we have the same x values, and this is a positive 18. Okay, so we have a positive 18 on the left side and also a positive 18 on the right side. So this is the same expression on both sides. And if you just want to rewrite them with the x's first and the numbers second to see it, this is really just negative 12x minus 18, because remember, we can reverse the order because addition is commutative, equals negative 12x, plus 18, negative 12x plus 18. So here we see the same expression on both sides, and this is infinitely many solutions. And if you don't see that, always take it the next step. So we would just combine like terms, so get the x's together first, add 12x, add 12x, and you would see 18 equals 18. That is the same number on both sides, so we have infinitely many solutions. The last one, again, we need to get rid of these parentheses, so 2 times 3x is 6x, 2 times 5 is plus 10, equals 5 times 2x is 10x, 5 times a negative 4 is a negative 20, and we have to bring down the negative 4x. I still don't see the solution because I have 2 terms on one side and 3 on the other. So I need to combine something on the right side since there's 3 terms. So I have a 10x and a negative 4x. I have 6x plus 10 equals, and 10 minus 4x is 6x minus 20. I see here that there is the same x value. Again, same x's, 6x and 6x. Different y values. Different numbers being added or subtracted. So therefore, this is no solution. And you can continue to solve, just minus 6x, minus 6x. You see, 10 equals negative 20. That will never happen. 10 will never equal negative 20. So there is no solution to that third equation. Here we have a release state exam question. So in order to solve this, what, if any, are the solutions to the equation below? We need to first start solving it. Get rid of these parentheses, and we also have 3 times 0.5x minus 4 equals 3 over 2x minus 1.2. So this also is a little bit tricky because now we have decimals and fractions. So in my eyes, I'd rather work with decimals rather than fractions. So I would change this 3 over 2, put that into the calculator, and see what it is as a decimal, and use that decimal instead of 3 over 2. Because if there are other decimals within the question, it's just easier to keep it consistent and use all decimals rather than having decimals and fractions. So on the left side, we'll start by distributing. So 3 times 0.5, which is a half. When you type that into the calculator, you get 1.5x. And 3 times negative 4 is negative 12, equals. If you typed in 3 over 2 in your calculator, we got 1.5 as a decimal. So I'm just going to change that to 1.5x and bring down negative 1.2. Now I need to get the x values together. So, or you can stop here. If you can stop here and see that this is 1.5x minus 12 equals 1.5x minus 1.2, you should see the x values are the same, but the y values are different. So if you are able to recognize that, you know that this answer will have no solution. And if not, like I would just do, I would continue solving. I'm going to get the x's together by moving 1.5x to the other side by subtracting it. And I have negative 12 equals negative 1.2. Those are not equal to each other. and that is no solution. Here is your summary. So again, we always add with a summary, so it's just some key skills and strategies that will help you identify equations when they have one solution, no solution, or infinitely many solutions. So I would at this point just make 3 bullets of what helps you remember when an equation will have each type of solution. All right, so take a minute and jot your own little notes, and then you could press play and come back. And this next slide is basically a checklist or a resource page. So if you want to print this out and keep it next to you to have when you're solving, it's like a little cheat sheet that helps you identify each type of solution. So it's just like a notes page. Basically everything, it summarizes for us everything. I've typed it up. And finally, the last slide of the lesson is the exit slip. So I highly suggest you try this on your own first and see if we get the same answers. And then you could click play and come compare them to mine. So the first one, once you finish solving, come back. We're going to go over them. If you can see that this is no solution because it's the same x values on both sides, the different numbers being added and subtracted, that is no solution. If not, solve it. Minus 8x from both sides to get the x's together. We have 10 equals negative 20. We know that is never going to be true. 10 will never equal 20. There is no solution. In the next equation, we have to distribute 3 times x is 3x. 3 times 2 is plus 6 equals, now we bring down 3x plus 6. We have the same exact expression on both sides. Therefore, this is infinitely many solutions. 3x plus 6 will always equal 3x plus 6. There's no way that they would be different. And if you don't see that though, go ahead and finish solving. Get the x's together, so we subtract 3x on both sides. And we could get 6 equals 6. And we know 6 will always equal 6 forever and ever. So that is infinitely many solutions. Over here, we see that the x values for the x coefficients are different. So we know that this will have one solution because the x's will not cancel out and they will solve for one x value. So let's see what that x value is. And if you were unable to identify it from the equation as given, just solve it. So we bring the smaller x to the larger, so we're going to subtract the 4x to bring over to the 6x. And we have 10 equals 2x minus 20. Now we need to get the x alone, so we need to move the negative 20 over. So we add 20 to both sides to combine it with the 10. And we have 30 equals 2x divided by 2. Get the x alone, divide by 2. And we have x equals 15, which is our one and only solution. And therefore, we are done.